Here is the question number 5. It says, evaluate the following integral using partial fraction decomposition technique. So first we notice, we write the fraction on the side, and we notice that it has two linear factors. Each of them is non-repeating because there is no power here. That means this can be decomposed into two fractions, one for each linear factor, and in the numerator we just have a constant. So that is the first step, to write the decomposition. The next step is to make the common denominator x plus 4, x minus 1. To make the common denominator, a will have to multiply with x plus 4 plus b will have to multiply with x minus 1. On the left hand side, we have x minus 1 times x plus 4. Now compare both sides. If you notice, we have the same denominator. That means the numerators should be same also. We are saying both of these statements are equal to each other. That should be true for all x. That means we can put in, say, x is equal to negative 4. Where I got this is from kind of the first factor. So let's put x equal to negative 4. On the left hand side, nothing changes. It's just 5. On the right hand side, when I put negative 4, this first factor is going to become 0. That was the purpose. Negative 1. 5 is equal to, this thing is just 0. Negative 4, negative 1 is negative 5b. That means b should be equal to 5 by negative 5. Answer is negative 1. So we already found b. We do need to find both a and b because we need to write the partial decomposition. We already worked x equal to negative 4. Let's try putting x is equal to 1. I got that from the second factor here. When I have to put it in the same equation. On the left hand side, it's just 5. On the right hand side, 1 plus 4 plus b, 1 minus 1. This is going to become 0. So basically 5 equal to 1 plus 4 is 5, a. A will be 1. So we found both of these. Using a value, b value, and the partial fraction split, I can write my integral as a by x minus 1. A is 1, so x minus 1. Plus b is negative 1 by x plus 4. So this is my partial decomposition using this and a and b values. I can separate it out, the integral 1 by x minus 1 dx minus, because there is a negative sign here, 1 by x plus 4 dx. So this converts into two simpler integrals. For finding this integration, you should remember the formula. Integral of 1 by ax plus b with respect to x should be natural log of ax plus b plus c. In this case, coefficient of x is just 1. Here is also coefficient of a is just 1. If it is a, then you have to divide by a. So here it's natural log of x minus 1 minus natural log of x plus 4 plus, always add a c when it's an indefinite integral. We are done. This is a good answer to write, but sometimes, because it's log of something minus log of something, you can also write it as log of x minus 1 by x plus 4 using the quotient rule of logs. So this is also a good way of writing the answer, but both of them should be acceptable. Here's the text part of that. Let's write the fraction below side first. X squared plus x plus 1. I notice that the first is the linear factor, but it's repeating 2 times. And the second is also linear factor, but that is not repeating. So because of the first, we will have two fractions. one with only x plus 1 denominator, and the second one with x plus 1 power 2 denominator, plus for the third linear factor, which is x plus 2, we'll have third partial fractions, and it's only repeating once, basically not repeating, so it's only one partial fraction. Now I make the common denominator. The common denominator always, a hint is, it's going to be the same as the left hand side. So x plus 1 square times x plus 2. What do I multiply a with to get the common denominator? We have to make the same thing. So we have to multiply one factor of x plus 1 and one factor of x plus 2 plus b. To b here, we already have x plus 1 whole square, so we only need to multiply it with x plus 2. For c here, we have x plus 2 in the denominator, so we'll have to multiply with x plus 1 whole square. Comparing the left hand side and the right hand side, we have the same denominator. That means numerators should be same. By writing this equation, we are claiming that this is true for all x. So we can put x equal to anything. Let's try putting x equal to -1. By doing all this, we are trying to find a, b, and c. That's our goal. And I got x equal to -1 using the first linear factor. So let's put it in this equation. -1 square plus -1 plus 1 is equal to a times. When I put -1 here, that's gonna become 0. Notice that. -1 plus 2 plus this factor is also gonna become 0. So this is 0, this is also 0. What are we left with? 1 minus 1 plus 1 equal to 2 minus 1 is 1, b. This cancels, that implies b is equal to 1. So we already found b. We can also put x is equal to -2. Where did I get that from? From the second factor. But I'm going to put this in the same equation. Let's try that. -2 square plus -2 plus 1 equal to, when I put this in the first factor, -2 in place of x, that is going to become 0 because there is -2 plus 2, plus this also is going to become 0 because -2 plus 2, plus c, -2 plus 1 whole square. Let's see what this is. 4 minus 2 plus 1. This is going to become 0. This is going to become 0. Only thing we are left with is the last one. -2 plus 1 is -1 square, +1. So we are just left with c here. And 4 minus 2 is 2 plus 1, 3. So c is equal to 3. So we also found c. Now there were only two linear factors in this question, so I've already got x -1 and x -2. Now we haven't found all a, b, c. We still have to find a, so we need another value of x. I would say use a convenient value which is easy to calculate. So let's put x equal to 0. When I put x equal to 0, again you put in the same equation. This will be 0 plus 1. A times 0 plus 1, 0 plus 2, plus b times 0 plus 2, plus c times 0 plus 1 whole square. Let's see what that is. 1 equal to, this is 1 times 2, 2a, plus 2b, plus c. We already know what b is and what c is, so we can put them here. 2a plus 2b, b is 1, so 2 times 1 plus 3 is equal to 1. That means 2a plus 5 is equal to 1. 2a is equal to -4. Subtracting 5 on both sides, a is equal to -2. So we have found all three constants, a, b, and c, and we have this partial decomposition. Using this, we can write our integral now as integral of a by x plus 1, so negative 2 by x plus 1 plus b, which is 1 by x plus 1 whole square, plus c, which is 3, we found it now, x plus 2 dx. So our integral is split into smaller, easier integrals. We can write them as separate. We can also just take 2 out. That would look like negative 2, 1 by x plus 1 dx plus integral 1 by x plus 1 whole square dx plus 3 integral of 1 by x plus 2 dx. Remember our formulas. Integral of 1 by a linear factor is 1 by a natural log of ax plus b plus c always. And if we have a linear factor, actually let's just write it like this, ax plus b's power n, that would simply use the power rule with 1 by a in the denominator. So let's write this down. This first one is just 1 by x plus 1, so negative 2 natural log of x plus 1. The second one here is, it can be written as integral of 1. Instead of the denominator, it can be thought of as x plus 1 power negative 2. So that is power rule basically. So power add and power divide, the new power, okay? So this is x plus 1 power negative 2 plus 1 by negative 2 plus 1 plus 3 natural log of x plus 2 plus c. Okay. This first thing this is good enough answer actually, but you can also, using the power property, this 2 can go in the power here. This is negative and this becomes square. Negative 2 plus 1 is negative. That's why this is negative. 1 by x plus 1. Because the power was negative, it can go down. Plus this 3 goes up here. So that is natural log of x plus 2 power 3 plus c. You guys notice that this and this together can be put into a log, combined log using the quotient rule, minus the second term. This one does not have any log in it. Don't mix in there. That is just separate. This is your answer. Now we can do this compact, but for the integrals, this is good enough answer, okay? But you can write it more compact and presentable like this.